Welcome to solverfy.
.96. So this is a problem about determining whether a particular painting was a forgery or not. We're not going to go through the whole story, which is very interesting though, but for the sake of time, we're not going to worry too much about the history. But basically, we want to determine whether the lead in a pigment in the painting was such that it was, whether it was 30 or something years old or 300 years old. And so here's a decay chain that we have. We're going to be mainly considering the radium and lead-210 and lead-206 parts of it. So the first thing we want to do is show that the rate at which the number of 210 atoms changes is equal to lambda 226 N226 minus lambda 210 N210. Now we can see immediately that this is just the activity of the radium minus the activity of the lead. So the radium decaying produces the lead-210, and the lead-210 decaying removes lead-210 from from the sample. So this is the rate at which you're adding 210s, and this is the rate at which you're taking them away, and so then that's the net rate of change of the lead-210. So for part B, well, so we're told that in the lead ore, because the half-life of the radium is much larger than the half-life of the lead, the nuclides of the radium and the lead are going to be in equilibrium, so the numbers do not change, and their concentrations don't change. So then we want to know what is the ratio of the radium to the lead in their activities. So if we just take this, if it's in equilibrium, excuse me, then the rate of change is 0. This being equal to the difference in the activities, implies then that their ratio R226 over R210 is equal to 1. See, we want to know what the ratio of their numbers is. And so we know that R is lambda n so N226 divided by N210 is equal to the ratio of their decay decay constants. And the 226, it's inverted. And then again, this is log 2 over the half-life. So now we have the half-life of 226 on top, divided by that for 210. And, oh, sorry, this is a typo. It's just 22.6 years. And so this is the 1.6 thousand years divided by the 22.6 years, or 70.8. So this is what we'd see in a unrefined sample of ore. And when it's refined, most of the radium gets taken out, and it sort of starts equilibrating again, and it'll go to this level. So now we imagine that only 1% of the radium is remaining after the ore is processed into a pigment. And so now we want to find what the ratios are again of the activity and the number. So the there's 1% of the 226 remaining in the pigment. So this just means that we'll have 1% of the activity from the 226 in the ore. And since that's right up here, we just multiply that by 1%. This we already saw was equal to 1 because it's in equilibrium in the ore. And so the ratios in the freshly refined pigment is 1%. And then similarly, the ratio of the numbers, there's only 1% of the radium, so it's just going to be 1% of the value we found previously, so 0.708. Now, so this person who is doing the dating of this painting discovered that the actual ratio in the pigment was 0.09. And so we're told that if it were painted, that year or something, it'd be close to the ratio in D. And if it had been painted 300 years previous, it would be close to 1. And since 0.09 is in this case, significantly less than 1, this implies that the painting was not 300 years old. And so it was not painted by Vermeer.